Today we are going to go over 9.3 part 1. How do we find the derivative and the second derivative? Given the function x equals ft, y equals g of t, the derivatives are given by the following formulas. dy over dx equals dy over dt divided by dx over dt. Because both x and y are function of t, so our answer will be also a function of t. Let's call it h of t. When we take the second derivative, we are going to take dh over dx. Because h and x are function of t, we follow the same rule, dh over dt over dx over dt. Let's have a look at example 1. Given x and y, try to find dy over dx and the second derivative. So first, dx over dt, we take the derivative, give us 1 over radical t. dy over dt equals 6t minus 2. Directly, dy over dx equals dy over dt over dx over dt, which is 6t minus 2 over 1 radical over radical t. We simplify it. We get this. Let's call it h of t. This is our first derivative. So second derivative, dh over dt over dx over dt again. You can write this bar longer. So this, when we take the derivative of the numerator, give us 9 square root of t minus 1 over radical t divided by 1 over radical t. Give us 9t minus 1. This is the second derivative. So let's have a look at next example. Given x and y, how do we find the equation of the tangent line? As we know, in order to find the line, we need a slope and we need a point. So the slope is given by dy over dx. And we find the point by plug in t equals 3 pi over 4. So when we plug in x, t into x give us 4 cosine 3 pi over 4. Give us negative 2 radical 2. When we plug in t into y, give us 3 sine of 3 pi over 4. Give us 3 over 2 radical 2. So this is the point, negative 2 radical 2, 3 over 2 radical 2. Now we find the slope equals dy over dx, which is dy over dt over dx over dt. So dy over dt, which is 3 cosine t. dy over dt, which is negative 4 sine of t. This is negative 3 over 4 cotangent t. And we plug cotangent t equals 3 pi over 4. So cotangent second quadrant negative, so our slope is 3 over 4. So we have a slope, we have the point, equation of the line, y minus equals slope times x plus 2 radical 2. Okay, this is the first derivative and the equation of the tangent line. Let's have a look at next example. Next example, we are going to talk about two very important tangent lines, horizontal and vertical tangent. So for horizontal tangent, as we know, for horizontal tangent, the slope equals 0. And the slope equals dy over dt over dx over dt. The denominator cannot be 0, so the numerator has to be 0. And the vertical tangent, the slope doesn't exist. So because the denominator dx over dt equals 0. So this is how we set up the vertical and horizontal tangent. So for example, this one, so dx over dt equals 0. This gives us vertical tangent. Make sure you label it. So this gives us 2t plus 1 equals 0. So t equals negative 1/2. Horizontal tangent, dy over dt equals 0, which is 2t minus 3 equals 0. So t equals 3 over 2. So keep in mind, we are not looking for the t, we are looking for the points. We have to plug this into x and y. So x equals negative 1/2 squared plus t equals negative 1/2 squared plus 3 over 2 plus 5. So the point when xt equals negative 1/2 is 11 So it's 1/4 minus this is negative 1/4, and then 1/4 plus 6, 7, 27 over 4. That's the vertical tangent. And the horizontal tangent, we do the same thing. We plug 3 over 2 in. So it's 9 over 4 plus 6, so it's 15 over 4 and 11 over 4. Okay, let's have a look at the next example. Next example, you can do it yourself. The only thing is, how do we find the slope at the point x and y here? So this is x equals 3, y equals 5. Based on this, we have to solve for t. System equations, our solution t equals 1. If you look at my answer key, so this is my answer key, and the second derivative right here.